You know, keeping an eye on our planet's forests is a huge job, and honestly, it's incredibly difficult. We're talking about millions of square miles of land, a lot of it super remote. So how in the world can we possibly monitor all of it? Well, let's dive into the amazing technology that's giving us a whole new way to see our planet from space. Okay, first, let's just take a moment to appreciate the sheer scale of what we're talking about here. This map shows that forests cover about 30% of all the land on Earth. They're absolutely massive carbon reservoirs. Get this, storing almost twice the amount of carbon that's in our entire atmosphere. So yeah, protecting them is a really, really big deal in the fight against climate change. But that massive scale, well, it creates a huge monitoring problem. These are living, breathing ecosystems that are always changing. And a lot of the time, they're completely hidden from our typical eyes in the sky.
And that gets us to the real heart of the problem, right? Traditional satellites, the ones that basically work like a camera, are totally useless at night. And they're completely blocked by clouds, which, if you think about tropical rainforests, is pretty much a constant state of being. We needed a way to see right through the darkness and the weather.
And that is where a completely different kind of vision comes into play. A technology that gives us a constant, reliable eye on our planet, one that can pierce right through the dark and any storm clouds. Let's meet our hero, Synthetic Aperture Radar, or SAR for short. Now, unlike a regular camera that just passively collects light, SAR is active. It sends out its own microwave pulses, and then it listens for the echo that bounces back from the ground. And that one simple difference gives it this incredible all-weather, day and night superpower. A really great way to think about this is like echolocation for a bat. You know how a bat sends out a sound and listens to the echo to build a map of its surroundings? Well, the satellite does the same thing, but with a microwave signal. By analyzing what comes back, it can build this incredibly detailed picture of the ground's structure and texture, showing us things a simple photo never could.
So this echolocation idea is cool, but how does it actually see a forest? I mean, a forest is a complicated, messy place. Let's break down how that works.
It turns out, not all radar is created equal. Different wavelengths give us different kinds of information. So as you see here, shorter C-band radar waves tend to bounce off the very top of the forest canopy. But the longer L-band waves, they can actually dive deeper, pushing past the leaves and interacting with the branches and trunks. That tells us a whole lot more about the forest's actual structure and how much biomass is there. But here's the thing. When the satellite first beams this data back to Earth, it doesn't look like a nice, clean map. What we get, as you can see here, is this distorted, unfocused stream of raw data. It's a bit of a mess, and it needs a lot of work before we can actually understand it. So to turn that messy data into something useful, scientists have to run it through a bunch of really complex corrections. They fix the distortions caused by hills and valleys, and they adjust the brightness of every single pixel. This whole process transforms that warped data on the left into the geographically accurate map you see on the right. And that's a crucial first step before any real analysis can happen. But even after all that cleaning, there's another quirky challenge that's unique to radar: speckle noise. It's this grainy, kind of salt and pepper texture you see. It happens because of the way the microwave pulses interfere with each other when they bounce back, and it can totally obscure the important details we're trying to find. And wow, this slide really shows you what a difference the solution makes. Scientists use these advanced filtering algorithms to basically wipe away that speckle noise. I mean, just look at the difference. What was once a grainy, confusing image on the left becomes this crystal clear, detailed landscape on the right, totally ready for analysis. Okay, so now we have this beautiful, clean radar data. So what? How do we go from just pixels on a screen to actually helping protect forests on the ground? Well, the secret ingredient is time. Here's the magic. Satellites like Sentinel-1 fly over the exact same spot every few days. This lets us build up a history, a time series, tracking the radar signal from one location over months and years. And what scientists discovered is that each type of landscape, whether it's a city or a dense forest, has its own unique and predictable radar signature. It's almost like a steady, consistent heartbeat. And this is where it gets really powerful. A healthy forest has that nice, steady heartbeat. But when something sudden happens, like a patch of forest gets cleared for logging, that heartbeat is broken. The radar signal, as you can see in this graph, just drops off a cliff as the trees disappear. That sharp change is a loud, unmistakable alarm bell for scientists. So what you can do is teach computers to automatically listen for that alarm bell, to spot those sudden drops in the signal. And the result? You get these incredible near real-time maps of forest disturbance. This map doesn't just show that logging happened, it shows you precisely when and where, right down to the week. It turns a fire hose of satellite data into truly actionable intelligence.
For decades, this kind of analysis was limited to just a handful of experts with access to supercomputers. But now, that's all changing. The future of this technology is wide open for everyone.
And what's really driving this revolution isn't just the tech, it's a whole new philosophy. The goal isn't just for some lab to create another map. As this quote says, the new approach is all about capacity building. It's about empowering local scientists and conservationists to use the data to build their own solutions. And believe me, this isn't just some nice idea. It is happening right now, on the ground. Through a global network of training workshops from Nairobi to Kathmandu, experts are training a whole new generation of users. They're putting these incredibly powerful tools directly into the hands of the people who are on the front lines of conservation. So what's making all this possible? It really boils down to three huge, game-changing trends happening at once. First, open data policies mean that this massive stream of satellite imagery is now free for everyone. Second, cloud computing means you don't need a supercomputer in your basement anymore. And third, open source software gives everyone free access to the powerful analytical tools themselves. It's the perfect storm.
When you put all of that together, it has completely changed the game. It has democratized Earth observation. The power to see through clouds and darkness, a power once reserved for spy agencies and elite research labs, is now in the hands of students, nonprofits, and local governments all over the world. So the question is no longer if we can watch over our planet. The question is, with this incredible new vision accessible to all of us, how will we choose to use it?